Hi everyone, this is Shahriar from Blaze Animation. In this video, I'll go through Blaze Puppeteer from beginning using the demo character that comes with the add-on. In this guide, I'll show you the setup first, then we will generate and refine some motions inside Blender. Welcome. Alright, first let's install the add-on. There are two ways to do this. You can either open Preferences either in Get Extensions or Add-ons tab, use Install from Disk, or you can simply drag and drop the downloaded file from Superhive directly inside Blender. The installation may take a little while because Blender needs to install the included packages, so just let it finish. After that, press N in the viewport to open the sidebar and you should see the Blaze Puppeteer tab. If you didn't, you can just simply go to Preferences, go to the add-ons, and simply disable and re-enable Blaze Puppeteer, and it should appear in the side panel. The first step is to set up our character. Make sure you're on the Rig Setup tab. Choose your character armature and then look at the Rig Preset section. If you are using a supported rig type, this can save a lot of time. You can choose a preset from the drop-down and press apply, or you can use Auto Detect. Auto Detect checks the selected armature, tries to recognize the rig type, and fills the FK, IK, spine, and root controller lists automatically. After applying a preset, quickly review the lists to make sure everything looks correct. If you make changes or if you set up a custom rig manually, you can also save that mapping as your own preset, so you don't have to rebuild it next time. For this tutorial though, we are going to continue the manual way first. That way you understand the logic behind the setup and you will know what to do when you're working with a custom rig or when a preset needs small adjustments. Now expand the reconstruction section. Here you'll see 5 chain sections: right leg, right hand, left hand, and spine. Each list needs to be filled in a specific order. You can assign both FK and IK controllers, but IK is optional. For the legs and arms, we start from the outer controller and move inward toward the body. So for the legs, that means starting around the toe or foot and going up toward the thigh. For the arms, we start from the wrist and go up toward the shoulder. Let me do this real quick. Also, notice that auto mirror is enabled. So if your character is symmetrical, you only need to pick the controllers on one side, and Blaze Puppeteer will automatically add the matching controllers to the opposite side list as well. Now, let's start with the right leg. You need to be in pose mode for this. You can either select each controller one by one and press the plus button here, or you can click the record button and then select the controllers one after another in the correct order from the toe up to the thigh. When you're done recording, click the record button again to stop. If you accidentally pick the wrong controller, you can remove it with the minus button. And if the order is wrong, you can use the arrow buttons to move items up or down. Now let's move to the right hand. We start from the wrist and we skip the fingers because fingers are not supported yet. Then we continue up the arm toward the shoulder. Great. Now let's do the spine. For the spine, you want to start from the inner part of the body, like pelvis, hips, or torso. Pick the controller that moves the whole body, like this one. And similar to retargeting, you should avoid spine controllers that drive downward chains on the lower body. For example, this one controls the lower body only, so I'm going to hide it for now so I don't accidentally pick it. Now we can continue from the torso, then chest, neck, and head. The root controller is optional. If your rig doesn't have a separate root or master controller, you can check no root controller. But if your rig does have a root or trajectory controller, and especially if you want to use root extraction later, then you should assign it here. Now we can press reconstruct. Then Blaze Puppeteer asks us to pose the generated rig into a T-pose first. Do this from the front view, straighten the arms and legs so the character forms a clean T-pose. Then confirm the front view, next check it from the top view as well. Adjust anything that needs fixing, then press Finalize T-pose. You may notice that some spine joints point in unexpected directions. That's normal. They are following the orientation of the original controller, and it won't cause a problem. What happened here is that Blaze Puppeteer created two proxy rigs inside the Blaze Puppeteer Meta Rigs collection. These are the armatures that get passed to the model for generation, either for local generation or when you're using motion refinement. One more thing before we leave rig setup, IK controllers. Even after reconstruction, you can still add IK controllers to these lists without reconstructing again. That's because the reconstruction itself is built from the FK controllers, or from the bones directly if you're using a character without a control rig, like a Miximo character. Now let's add the IK controllers for this Rigify rig. You can see these fields in front of each item in the FK list. This is where we assign the matching IK controller for that FK controller. But we don't add IK controllers for every item. We only add them where the rig actually has a corresponding IK controller. One very important rule: under no circumstances should the pole target controls be added to the IK list. For the legs, on most standard rigs, you will have an end effector IK controller that controls the whole foot chain. In most cases, this controller should be assigned in front of the foot or ankle FK controller. You would almost never put the foot IK controller in front of the toe controller. If you do, you may get strange foot or toe rotations when the motion is applied. In some rigs, only foot IK controller is enough for the leg, but some rigs also have an IK controller around the thigh that controls the knee bending direction. Earlier, I said we should not use the pole target. This thigh IK control is the replacement for that. On Rigify rigs in the rig setting, you can turn off the pole target option, so the knee direction is only controlled by the thigh IK controller instead. That's the setup we want here. So now we add the foot IK controller in front of the foot or ankle FK controller. Then we add the thigh IK controller in front of the thigh FK controller. The same principle applies to the arms. The hand IK end effector goes in front of the wrist FK controller, and if the rig has an upper arm IK controller that controls the elbow bending direction, with the pole target turned off, we add that in front of the upper arm FK controller. Now, when you generate a motion, Blaze Puppeteer can apply the result to both the FK and IK controllers. But when you create anchor poses, make sure you pose the character using the controllers you actually want to work with. Those anchor poses are captured from your rig, and after the generated motion is applied, Blaze Puppeteer corrects the motion so the anchored poses match what you posed originally. We will talk about anchors later in this video. This rig setup walkthrough was done with our demo character, which is rigged with Rigify. If your character uses one of the supported rig presets, you can start from a preset, apply it, and then look through the generated setup to better understand how the controllers are mapped. Let's review the motion tab. At the top, we have this account bar. This is where you can log in to access online features like custom prompts and motion refinement. Motion refinement will show up once you have a generated motion in the history section. Right below that, you will see the rig setup status. If it says rig setup ready, then you're good to generate. But if it says reconstruction needed, you need to go back to the rig setup tab and run the reconstruction again. Next, we have preset prompts and custom prompts. Preset prompts currently include 130 local prompts that you can use without spending credit. Custom prompts lets you type your own motion description. When you generate with a new custom prompt, it uses 1 credit, but after that, the prompt is saved locally. So if you want to use the same prompt repeatedly, you don't need to spend another credit. One quick note, we are also planning to make custom prompts and motion refinement available offline without needing credits. So by the time you're watching this video, we may have already released an update that includes offline access for those features. And if not, keep an eye out for new updates. We have 4 generation modes: Inbetweening, text to motion, waypoint, and dense path. All of these use a prompt as a default guide. Inbetweening lets you set specific poses at the specific frames, like blocking. The generated motion will then try to hit those poses on those exact frames. These poses are called anchors, and we will talk about them in a moment. In the prompt section, if you click the 3 dots, it activates multi-prompt mode. This lets you use different prompts at different parts of the animation. When you click on Prompt Sequencer, Blender opens the video sequencer. From there, you can press D to create or remove prompt strips, and then adjust their timing and length directly in the sequencer. When using multiple prompts, the motion needs enough time to transition from one motion to the next. How much time it needs depends on how different the prompts are. So, if the first prompt works well, but the second one doesn't seem to match the prompt, it probably just needs more frames to transition. If you press E in the sequencer, you can edit the prompt strip under the current frame. You can also adjust duration, edit prompts, or remove strips directly from the panel. Now let's create some anchors. You can use these buttons here: full body, hands, or feet. If you click more, you get more control, so you can choose left hand, left foot, and right foot separately. You can also use shortcuts. Press F to create a full body anchor, or press D outside the prompt sequencer to create a hands and feet anchor. A full body anchor locks the whole pose at that frame, but if you anchor only the hands or feet, the generated in-betweening motion only tries to match those specific body parts at that frame, while the rest of the body stays more flexible. As you can see, when we create an anchor, a marker is added to the timeline. The marker name starts with Pop A, which stands for Puppeteer Anchor. FB means full body, H plus F means hands and feet, and names like LH plus RF means left hand and right foot. So once you know the naming pattern, it is easy to read. You can use the plus or minus button to add or remove an anchor at the current frame, and the X button removes all anchors at once. Next we have badges. I'll set the visibility mode to always so they stay visible. Badges are these small squares in the timeline. They represent your anchors visually. If the badge is yellow, it is a full body anchor. If it is divided into 4 sections, like this one, the top half represents the hands and the bottom half represents the feet. The left side is the left hand or foot, and the right side is the right hand or foot. There are also these thin rectangular anchor indicators called bars. Bars show the anchor positions in a cleaner, more compact way. If you want a less crowded timeline, you can switch the badge visibility to bars only. We also have ghosts. Ghosts are the stick figures you see in the viewport, and they show the anchored poses. If the ghost is yellow, it represents a full body anchor. Otherwise, it appears gray with only the anchored body parts highlighted in color. In the timing section, we can either set the motion duration manually or switch the timing mode to anchors. When it is set to anchors, Blaze Puppeteer automatically sets the generated motion range from the first anchor to the last anchor. There is also a preserve outside range option. When this is enabled, Blaze Puppeteer keeps your existing animation before and after the generated range. So if you're only generating a section in the middle of an animation or extending an existing animation, the keyframes outside that range are preserved instead of being cleared. This is especially useful for in-betweening because you can replace or add motion manually where you need it while keeping the rest of the performance intact. Now let's generate a motion. We already have some anchors set. A full body anchor, a feet only anchor, another full body anchor, and lastly a hands plus feet anchor. The duration is 100 frames and we set the prompt to something generic from the preset prompts, natural human motion. This is useful when you don't want to use a custom prompt, but there isn't a preset prompt for the exact motion you have in mind. Now let's hit generate. Let's compare the result to our anchors. Here in the history section, the upper action is the most recently generated one, and at the bottom is the action where we set our anchors. Frame 1 matches exactly. Frame 25 matches the feet because this was a feet only anchor. Frame 71 matches our full body anchor, and frame 95 matches the hands and feet from our last anchor. Now in the history section, if you hover over the generated actions, it shows information you may need later if you want to reproduce the same motion. For example, the seed. Now let's expand the seed section. The seed value controls the variation of the generation. If the seed value is set to -1 or you choose random, each generated motion will be different from the previous one. But if you set the seed to a positive number, then using the same settings and guides, reproduce the same results. This helps when you like the style or timing of a generated motion, but you only want to adjust your anchors, waypoints, or other guides slightly and generate again. Now let's open Graph Editor to see how unbaking works. When we expand the post-processing section, you can see that we have extract root motion and unbaking here. We will talk about extract root motion in a moment. Now let's, for example, select this controller. As you can see, the motion is baked, meaning there is a keyframe on every frame. That can make the motion harder to edit if you want to polish the animation by hand. So when you activate unbaking, Blaze Puppeteer reduces the number of keyframes and tries to keep the curves as close as possible to the original motion. For unbaking, we have 3 levels: low, mid, and high. The higher the level, the fewer keyframes the unbaked motion will have. But the curve may also drift a little more from the original baked motion. The default value is mid, and it is good enough for most cases. Now let's talk about extract root motion. Extract root motion only works if you assign the root controller in the rig setup. If your rig does not have a root controller assigned, Blaze Puppeteer cannot extract the trajectory onto it. When extract root motion is enabled, Blaze Puppeteer takes the character's movement through the scene and transfers that trajectory onto the root controller. So instead of hips carrying all the word space movement, the root controller gets to move through the space. This is useful if you want a cleaner animation setup after generation, especially for game-style workflows, locomotion cleanup, or any rig where the root controller is expected to carry the character's path. Let's enable it and apply it to the generated motion. You can also enable extract rotation. This transfers the character's facing direction to the root controller as well. And there we have ground tracking. Root extraction only moves the root controller on the ground plane, so its height never changes, unless you enable ground tracking, which then adjusts the root controller's height in case you need it. These two options are not needed for every animation, but when the shot calls for it, they can help keep the root motion cleaner and easier to use. Now let's talk about the advanced section. In the advanced section, we can adjust some internal Kimodo settings. Denoising steps controls how many diffusion sampling steps are used for generation. The default is 100. You can reduce it to 50, and in many cases that may be enough. Or you can set it to 200 if you need a stronger adherence to the guides, although that is not guaranteed, and sometimes fewer steps may actually perform better. So I suggest leaving this at the default for most cases. Text CFG and constraint CFG control how strongly the model follows the text prompt and the other guides. Text CFG affects the prompt influence. Constraint CFG affects guides like anchors, waypoints, and dense path. This is also better left at the default in most cases, but it may be worth experimenting with in rare situations. Height compensation is useful when the character starts above or below the normal ground level, especially in modes like text-to-motion, waypoint, or dense path, where there may not be anchor poses to tell the model the exact starting height. Here we have an example, a character running on the ground. Let me show you. Before generating the motion, this was the initial position of the character. Now if we go back to our generated motion and enable height compensation, you can see Blaze Puppeteer now takes that initial height into account when applying the generated motion. So the results start from the character's current height instead of forcing the motion back to the ground plane. For Inbetweening, your anchors already provide pose and height information, but for modes without pose anchors, height compensation can help preserve the character's starting elevation. Next we have Keep Kimodo Warm. Keep Kimodo Warm keeps the local Kimodo worker loaded between generations. That makes the next generation start faster, because the model doesn't need to fully load again. The trade-off is memory usage. If you want faster repeated generation, leave it enabled. If you want to free memory when you're not generating, you can turn it off. Now time for waypoints and dense path. Before we use waypoints and dense path, let's quickly clarify what they do. Waypoints let you place points in 3D space at specific frames. The generated motion then adjusts the character's trajectory so the character reaches those points on those frames. The exact path between the waypoints may change from one generation to another, especially with a different seed, but the character should still pass through the waypoint positions at the specified frames. Dense path works a little differently. Instead of placing separate points at the specific frames, you draw a trajectory for the character to follow over the motion duration. The character moves along that path, but the model decides the timing. So you control the shape of the trajectory, but you don't directly control which exact frame reaches each part of the path. If you combine dense path with waypoint, you get both kinds of control. You can draw the overall trajectory and then place a waypoint on a specific part of that path so the character reaches that position at a specific frame. In addition to the buttons above with the different motion modes, these are here for times when you want to use Inbetweening together with waypoints or dense path, and you should check their boxes for them to be enabled along with Inbetweening. If you choose either of these two motion modes, you can still combine them with each other and use text prompts with them. But Inbetweening cannot be used in that case. When using these modes, you don't need to check their boxes for them to be enabled. As you can see, there are no checkboxes here. Only if you want to combine them, then you need to check the box. In this case, we are in waypoint mode. If we check the dense path box and draw a path, then we can use both to generate a motion. I'll switch to Inbetweening to run a test, combining Inbetweening anchors with waypoints and dense path. A waypoint is created where you click on the screen and it belongs to the frame you're currently on. One important thing to remember: the first waypoint, meaning the earliest frame that has a waypoint, should be where the character already is at the start of the motion. The first waypoint marks the beginning of the trajectory. If it starts far away from the character's current position, the generated motion will be wrong. Okay, remember, if we have waypoints set and we want to use them along with in-between anchors, we need to check this box, otherwise they won't be considered as a guide for the generated motion. Let's also draw a trajectory using dense path. Just like with waypoints, the start of the dense path should be close to the character's initial position before generation. Now I'm going to move the anchor positions so they match the waypoint and dense path. This is important because if we have conflicting guides, the model gets confused about which guide it should satisfy. For example, if the anchor says the character should be here, but the waypoint or path say the character should be over there, you end up with weird results. Now let's hit generate. Now what is Kimodo motion correction? Kimodo motion correction is enabled by default. When enabled, it reduces foot sliding, and in in-betweening, it helps make sure that the anchored frames are hit exactly. The raw generated motion from the model may still be slightly away from the anchored poses, so motion correction helps enforce those anchors after generation. One thing to keep in mind is that unbaking may still introduce a slight foot sliding, even with Kimodo motion correction enabled. The last major feature we need to cover is motion refinement. Motion refinement gives you three options: variations, extend or shorten, and loop. Let's start with variations. When you click the variations button, Blaze Puppeteer creates a new version of the selected motion. The number of results it generates is controlled by the variant count that you can change from here. Each variation is based on the current motion, but it may change details such as posing, timing, and it doesn't adhere to the guides you usually use for anchors, waypoints, and dense path. It doesn't take those into account. It generates completely independent variations with natural looking motion. Since generating normally with a random seed already produces a different motion each time, you may not need the variation tool very often. It is mainly useful, for example, when you want to generate several variations at once and you care more about exploring different variations than satisfying specific guides. Next, we have extend or shorten. This lets you change the length of the selected motion, extend it or shorten it as you prefer. However, you can also extend an animation without using motion refinement. To do that, use the last few frames of the existing animation as anchors at the beginning of a new generated range. That generates the next section. This gives the model the ending poses of the existing animation, helping it create a smooth transition into the newly generated action. Just make sure preserve outside range is enabled. That way your existing animation remains intact while the new generated motion is added after that. Finally, we have loop. Loop is pretty straightforward. Select the motion you want to loop, then click the button. Blaze Puppeteer then processes the motion, so the ending transitions back into the beginning, giving you a repeatable animation cycle. As it was the case with variation and extend, the results here are not guided by anchors, dense path, or waypoint. So always review the transition and do any final cleanup needed for your shot if it needs to satisfy any specific guides. Now let's take another look at the history section now that we have some generated motion refinement actions. Whenever you use motion refinement, the refined results appear as a child of the motion it was generated from. This creates a hierarchical structure, making it easy to see which variations, extensions, or looping motion came from which base motion. Now let's talk about the buttons here. If you select the base motion and choose Purge Drive, Blaze Puppeteer then removes all of its children. All motion refinement generations that are derived from that base motion will be removed. This is useful when you want to discard all the generations that you made with motion refinement. Remove selected deletes only the action currently selected in the history section. If that action has derived motions beneath it, those children are not part of this single action removal and they will remain in the history section. Use this option when you only want to remove one specific result. Remove family deletes the entire motion family. That includes the base motion and all the motions derived from it. Use this when you no longer need the original generation or any of its refinement results. Clear armature removes all generated motions associated with the current character armature. So if you want to remove all the generated motions for the current armature that you're working with, you can click on this button. And with that, we've covered all the main features of Blaze Puppeteer. Thank you for watching this tutorial. This was a broad overview of the complete workflow from rig setup and motion guides to generation, post-processing, refinement, and history management. There are still many ways to combine these tools and use them in real animation workflows. We may explore those techniques in more detail in future videos, so make sure to subscribe so you don't miss them. Thanks for watching and I'll see you in the next one.